Okay, so today we're actually gonna do a diode question with how to find the Q point of it. So here's a question we're gonna work on today, and just a quick summary. For diode question, the first step we do is always we want to find out what we know, which is for all the questions. So first, what we know. For this specific question, there's a circuit diagram here, and where's the ground and everything is pretty important. And two, we need to assume which model we're going to use to solve this question. And there's three models we can use. The most easy one, ideal model. I'm an engineering student. I don't know how to spell, so it's okay. Second one, constant voltage drop. In this case, they will usually tell you V on equals 0.7 or whatever number. 0.7 is a typical number. Or we can use load line analysis, which is a real world analysis because it's based on all the data. In this question, we're going to use ideal model. And the third step is we need to assume state. For diode, there are two states, on or off. When they're on, we consider them as short. When they're off, we consider them as open. So here we go. Let's find the case one. Case one, first step. I guess we skip that. We're gonna make assumptions based on our diodes here. They're on or off. So what I'm gonna do, I'm gonna just go ahead and assume diode 1 is on. Diode 2 is off. Why I make this assumption? It's because we can see here is 6 volts and here's ground. We know current flows from high voltage to low voltage, so I assume maybe here's a current flow this way. So seems like my D1 could be on, right? And here's minus 9 volts. What that tells me? Here's 6 to minus 9. Minus 9 is way lower than positive 6. So there seems like current might flow this way, which means this diode will be off, because if I want it to be on, my current will flow from the cathode side to the anode side, which means it's off. So that's my assumption right here. Good way to do it is always redraw the circuit. Always redraw the circuit. Here we go. I'm redrawing the circuit. I have my positive 6 volts. Goes through my resistor, 43 kilo ohms. There's my junction. And now I have my D1. Since I assume D1 is on, it's going to be short. And then go to ground. Here's our D1. Even though it is short, we do need to keep track of the polarity of it. Here's positive, here's negative, because at the end, we need to write KVL for it. Okay, so there's my D1. Then here goes my D2. I assume it's off, so it will be replaced by open circuit. There's my another resistor and my minus 9 volts. Here we go. Here's D2 and minus plus. Okay, so now we redraw our circuits, and what we need to do is write KVL. Don't think, don't doubt, always write KVL after you redraw the circuit. That's where you're gonna go when you have diode questions. Don't quote me on it, that's just what I've been doing so far. Okay, so now since we have two diodes, I want to have two equations, right? Two unknown, two equations, sort of things like that. So for my D1, I start from top to bottom. And what I need here is also current, because our KVL is based on Ohm's law. So I will say here is I total, because I want to call here is I1 and here is here's I2. Okay, so now our D1. Start at 6 volts, start with, and minus IT, I total times 43 kilo ohms, right? When you have resistors, it's always subtract with the current floating direction. And then here's plus and here's minus, which means I'm gonna minus VDI, right? It's from plus to minus, it's minus, equals ground, which is 0. So here's my first KVL equation for D1. Then for D2, for D2, same thing. We're gonna start with plus 6 volts, and then minus IT times 43 kilo ohms. Then we have open here, but we had to consider there is a voltage drop, VD2, since it's from minus to plus, so it's plus VD2. And then, oh, sorry, I forgot the resistor here is 22 kilo ohms, 22 kilo ohms. So we have minus I2 times 22 kilo ohms. Then I have minus 9. It might throw you off, but we always minus 9. I don't care it's plus or minus, I just subtract it. Then equals 0. So there's my two equations. Now we can think about how to simplify it. So first, we know our D1 is being shorted. So what that means? Means our voltage drop across a wire is 0, right? So this whole part, gone. And then we can look at D2. It's open. What that means? Means there's no current going through, right? So any term has I2 in it will be gone, which is this term right here going away, equals 0. So let's simplify it. Let's call this equation 1, equation 2. So from equation 1, we can get 6 minus I total times 43K equals 0. What can solve for it? We can solve for IT. Well, equals 0.14 milliamps. I cheated. So you can go through the calculation yourself. Plug in your calculator. Shouldn't be hard. And then let's solve equation 2 with what we got here, which is I total equals 0.14 milliamps. Okay, let's do the math. 6 minus 0.14 milliamps times 43 kilo ohms plus VD2 minus 9 volts will give you plus 9 volts equals 0. One equation, one unknown, right? Milliamps and kilo ohms cancels out. Not cancels out, I mean milli and kilo cancels out. So we'll solve that, give us VD2 equals minus 9 volts. We're not done yet. We have to check our condition based on our assumption. So we assumed D1 is on and D2 is off. So let's check. D1 is on, which means our current for D1, which is I1, has to be greater than 0. And based on our assumption, we know IT will equals I1 because I2 equals 0. So our IT which is I1 equals 0.14 milliamps, greater than 0. Check. It's good, because that's our assumption. Then we assume our D2 is off. So the required for that is our voltage for D2 will be negative. And we got our VD2 is -9, it's less than 0. So correct. Our assumption was correct. Now what we need to do is write down the Q point. So our D1, I like to go by current and V because we want IV curve. So our D1 will be current, which is 0.14 milliamps, and 0 volts because the voltage drop across perfect wire is 0. And for D2, our current will be 0 milliamps because we assume it's open, and the voltage drop is -9 volts. So here is our answer. Ta-da! Check. Thank you.